Today we are discussing about lexical analysis. Lexical analysis is the first phase of compilation which takes source program as input and generates tokens as output. Those tokens are given as input to the parser. Here the parser is used for generating the parse tree. So here the lexical analyzer while generating the tokens it is divided into two parts. One is scanner which reads the source program input character by character, and the second one is a token generator. Token generator is used for generating the tokens. So lexical analyzer is not only used for generating the tokens, it omits the white spaces as well as comments, and at the same time it takes care of line numbers. It generates a data structure in the symbol table for identifiers as well as constants. Here the identifiers may be the variables as well as function names. Why we are separating the lexical analysis with parser? So in the parsing we are constructing the parse tree where we are identifying or we are checking for the syntactical meaning of each instruction in the given source program, whereas the lexical analysis phase, what are the tokens we are having in that particular source program, what are the small amount of strings which are present in the given program. So why we are separating these two things means by separating lexical analysis with the parsing, we are improving the efficiency of the compiler design. Efficiency of the compiler by designing it, and it simplifies the design of the compiler, and it enhances the portability of the compilation process. So here by making use of lexical analysis, we are identifying the tokens. Before identifying the tokens, first we need to check generate the Lexemes. So whenever the input buffer stores the in source program instructions character by character, so that whenever a meaningful string has been formed, that meaningful string is called as a Lexeme. For example, if we are having int a is equal to 10, so that there is a space in between I and after I and t, there is a space in between t and I. So this I and t will be treated as a string, right? So that meaningful string is called as Lexeme. So how by making use of these Lexemes are given to the token generator, so that token generator will identify whether it is a token of whether we can form a token or not by making use of the patterns. So here that what is pattern means, for each and every token there is a specific pattern. For example, if we are having an identifier means it should start with an alphabet, and then the second letter onwards, the second character onwards, it may be a character or that means alphabet or a number. So that type of pattern has to be identified. Then it will be that particular Lexeme. The Lexeme will be given to the pattern, so that the pattern will identify whether what type of token it is. So for example, if it is a number or a constant, so that all should be digits. So that means we will be given with some set of patterns. So Lexemes are matched with those patterns. To which pattern it has been matched, that type of token has been generated by the lexical analyzer. So this Lexeme means it is a sequence of characters, that means it is a meaningful characters. Suppose here, if we take if as a simple in a particular instruction or in a source program instruction, if there is an if, so I and f are the characters, and if we combine this I and f, that will be given to the pattern, so that it will identify if as a keyword. If we take E is equal to MC square, here E is an identifier because in between E and equal to there is a mismatch, because E is a character as well as equal to is an operator, so that only E will be taken and that will be identified as an identifier. Equal to is an assignment operator, M is again identifier, and this is multiplication operator, and then C is again identifier, then exponential operator, and then 2 is a number. So like this it will identify the tokens. So as we have already already discussed in the lexical analysis phase, we are going to scan the data by making use of scanner. That means the source program will be scanned and that will be stored somewhere to identify the lexemes, and those lexemes will be given for the token generator to generate the tokens. So here we are having input buffer which stores the source program instructions into the input buffer character by character, and from this input buffer we are going to get the lexemes. So the instruction, if we store the total instruction in the input buffer, so that how we can identify the token is, here we are for identifying the lexeme, we are going to make use of two pointers. One is beginning pointer and forward pointer. At the starting stage, both beginning pointer and forward pointer points to the same location, and after that, whenever we are going to read the next character, the forward pointer will be incremented by 1 until and unless a white space has been encountered or there is a mismatch in between the present character and the next character. If the next character is some other, it is not matched with the present character, then the forward pointer will be decremented by 1 the characters in between lexeme, beginning pointer and forward pointer will be treated as a lexeme, and that lexeme will be given to the token generator, and that token generator will identify what type of token it is by making use of finite automata. That means by making use of a tool called as Lex tool, Lexical Analyzer generator. So whenever we are storing this input string, input statement, that means source program statement in the input buffer, there is a chance of having large amount of data in a single statement, so that we may not be able to store that statement in a particular buffer. That is why we are dividing this input buffer schemes into two things. One is one buffer scheme as well as two buffer scheme. If we want to store the data or instruction, so that if it is a small amount of data if we are having, so that we can store the data in the one buffer scheme, so that we can store the data, and then from that we can identify the lexemes, and those lexemes will be given to the token generator. Suppose if the size of the instruction is large, so that we can go with two buffer scheme. Here in two buffer scheme, after storing the instruction in the one buffer, and then the remaining statement will be stored in the buffer 2. So that by combining buffer 1 and buffer 2, we can easily identify the lexemes. So while we are identifying the lexemes, or else while we are identifying the token, there is a chance of having, that means after identifying the token lexemes, those will be given to the token generator. Then token generator will identify the tokens. So for identifying these tokens, we are going to make use of token generator. This token generator will make use of regular expressions as well as regular languages, and at the same time it makes use of finite automata for identifying the tokens. Generally, in every programming language, the tokens may be either identifiers or constants, or that means constants means numbers, or operators or special characters, and keywords. So how we are differentiating them means, if there is a string, so that we need to identify whether it is an identifier or a keyword. So in every programming language, we will be given with some specific keywords, so that if that particular lexeme is matched with any of these keywords, then we can easily say that it is a keyword. Otherwise, it should be given to the identifier, so that we need to check whether it follows the pattern of identifier or not. Here, one simple pattern for identifier is, it should start with letter, and second character onwards, it may be a letter, that means alphabet or digit. So while we are after scanning the input by using input, after the scanner will scan the input, and that will be stored in the input buffer, and then that will identify the lexeme, and that will be given to the token generator. Token generator will make use of finite automata for identifying the tokens. So while identifying the token, there is a chance of having errors, like we may not be able to generate the tokens at that time. We are having some error recovery schemes. That means if we are unable to generate the token, then this lexical analyzer will generate some error message to the error handler, so that error handler will handle that error by displaying that error to the on the screen, so that the user can easily identify that particular error and he can rectify it. So we are having some set of errors, like for example, instead of printf, if I write only print. While I am typing a statement, instead of printf, if I type print, then there is f missing. So that will be identified and that will be given to the user so that he will rectify that. In place of one character, if we place another character, there is a transpose of character. Like that, errors will be identified and those will be given to the user so that he will rectify. This mode of error recovery is called as panic mode error recovery scheme.